No. Alright, so 4.1, we have absolute extrema and the mean value theorem. So Chavez wanted some mean stuff, so there's your statistical reference. It's as good as it's going to get. Okay, so we've got some pieces in here. Absolute minimum. We have absolute stuff versus relative. So basically, let's say I have a function that looks something like this. Okay, so some kind of W-ish thing. Okay, so we have some different mins and maxes going on. This piece right here, you guys see where I'm referencing? What would that be called?
Local.
Okay, local. In this text, they call it relative. But yes, that would be the same thing. So a relative minimum. What about this one right here? Relative max. Okay. The absolute lowest spot is called the absolute minimum. And what about my absolute maximum? There is none on this particular function. It's going to infinity. So there you go. It's infinity. Okay, so everybody understands the difference between absolute and relative.
Early release tomorrow.
Yes? No, we're talking about.
Sorry. I got this right.
Okay, do you know what an extrema is?
Yeah, it's extreme values are either maximum values, maximum.
The Latin root.
Okay, an extrema is simply a max or a min. Okay, it's not going to be the absolute, it's not going to be a relative, it's just one of those places. So the only way for you to find an absolute min or max is for you to plug in where the extrema exists, the x value, find the corresponding y value, and see by using the y value which is highest and which is lowest. Okay. Critical numbers, these are critical. Okay, what is a critical number? Okay, a critical number are the x values at which the function exists, but the derivative is either 0 or undefined. Okay, so a critical number is where we're going to find extremas most of the time. Okay, so we're looking for where the function is set equal to 0 or undefined. Okay, so meaning a vertical asymptote, right? Potentially. Okay, so procedures to finding our extrema. Okay, if they ask us for an absolute extrema, we would start by finding the critical values. Those are going to be x values, and then all we have to do is find the corresponding y values and see which value is going to be the biggest or which value is going to be the lowest. Sound good? All right, let's give her a go. Oh, we better read the note. I'm sure they wrote this in here for some reason. It says the absolute extremas can occur either at critical numbers or at endpoints. Okay, so if you have a function that is defined within an interval, like the drawing here below, then it's possible for your endpoints to be maximums or mins. Okay. So let's give it a go on this, we'll call this a piecewise function of some kind. Looking at this graph, can you tell me what the absolute minimum of our function is? Anybody know what the absolute minimum is? Shh.
4.
Or excuse me, did I say minimum? I meant to say maximum. Sorry, I should read closer. Sorry, my bad. Okay, it says maximum there. So yes, the absolute maximum value is 4. Okay, we're talking about that exact point right there. It is the highest spot on our interval between -4 and +4. Okay, at what x value does the function have a absolute minimum? Maximum. Oh my gosh, you guys, I cannot read today. Absolute. Okay, so the x value, where that exists, is -4. Thank you. Okay, so a thing for you to note there is if they're asking for what is the absolute max, what kind of value are you describing? The y. So this question we were telling them the y value, okay? And it didn't specifically say what is the y value, right? Okay, so just make a note that if they ask what is the absolute max, you're telling the y value. Okay, so for question 3, let's see if I can read this right this time. What is the absolute maximum point of the function? Negative 4, 4. Good. Okay, so just be aware they're going to ask you different things. Okay, points I think are pretty obvious. It's straightforward. X value, again, straightforward. But the max, I think that's maybe the least straightforward. All right, question number 4. This is the one I've been waiting for, apparently. What is the absolute minimum of this function?
I know.
Okay, so Hunter said, wait a second, there's like a hole there. Okay, so can we specify the exact location of where that function is going to? Okay, so we can't say like, oh, it's going to end exactly right here. Okay, we know that it's infinitely close to -2, but we can't say how close to -2 it is. So this function would have no absolute minimum because there's a hole there. Okay, so, wow, none. Wow, okay, none. Okay, so holes are infinitely close, but they're not exact values. Okay, at what x value does f have a relative minimum? Okay, I heard. What'd you say? -3. Agreed. 1. Oh my gosh, I cannot write today. 1. Okay, anything else? And 2. Very good. 2 is a relative minimum because there's kind of like that, I don't know, that little point that exists below the function, so it's a minimum spot there.
Sure.
What about number 6? Can you tell me the x values where you have relative maximums? Thank you. X values where we have relative max? Relative max?
-1.
-1.
Yeah, so
And that's it. Yeah, that's it. That's all you can do. You can't say that 2 is a relative max because there's a hole there. Okay, it's not a point. So that's it. All right, so that was pretty exciting. All right, let's do something with a function. Okay, so finding an extrema, so this one is finding the global extrema, so this is going to be like the absolute highest value and the absolute lowest values. Okay, so the interval, by the way, that they're giving to me is what kind of values? What kind of values is -1 and 3? Well, they're the x values, okay? So it's an x value interval. So we're looking for where this function has the highest y value and the lowest y value between that interval. So what am I going to do first in order to find an extrema, or let's just say a critical number?
derive
Set, okay, so first I have to derive it, and then I'm going to set that equal to 0 so that I can find where the slope is either 0 or potentially undefined. So what is the derivative of 1/3 x to the third? Okay, so if I set that equal to 0, okay, I can pull an x out, and then I would have x minus 2. So would you agree that I have two critical values here?
Yeah, I was about to say, where'd you get that to?
Oh, yeah, I don't know where I got the 2. I think I haven't done math all week, and it's just throwing me. I know, I've been giving tests all week. It's like the first time I've taught all week. It's throwing me off. I should just doing the dirty work. Okay, so 0 and 4. All right, so the critical values that I'm looking for are the values that are existing between my x interval. Okay, so which critical value is going to exist between -1 and 3? Just the 0. So the 4 is going to become irrelevant because it's outside of my range. Okay, so now what I have to do is I have to figure out which one has the biggest y value, which one has the smallest y value. So how would I decide that? Plug them in. Okay, so I'm going to plug in 3 different spots. I have to plug in my 2 endpoints because it's possible that the endpoints are higher than my critical values. So if I plug in -1 into my function, I would have -1/3 minus 2, right? Would you guys agree with that? And -1/3 minus 2. 2 is the same as 6/3. So that gives me what? -7/3. Okay, that's pretty low. What's the next critical value I'm going to plug in?
3.
I will do 3, but yeah, I'm just going to keep it in order. So I'm going to go to 0 next. If I plug 0 in, I don't know if you need to write this all down, but I would then get 0 out. And last now, if I plug 3 in, ooh, this one's more exciting. So 3 cubed is 27. 27 divided by 3 is 9. And then 3 squared is 9. 9 times -2 is -18. So 9 minus 18, -9. Okay, so can you tell me what the max, where the max occurs? Okay, max is at f of 0 equaling 0, and the min is at f of what? 3 equaling -9. How'd you do there? Not too bad? Okay. Alright, question number 8. So this question has a function that is an absolute value. Okay. Does anybody know how to derive an absolute value function?
Yeah, it's on the right.
Well, remember that the derivative is simply a slope, depending on where you are. You know that if I was going to graph this function, this is actually easiest to do graphically. If I have an absolute value of x minus 2, the x minus 2 shifts it in which direction? To the right, yeah. So to the right 2 units, and it's just a v, right, with a slope of 1. Okay, so it would look like, oh, I totally missed, like that. Okay, so just looking at that,
Can't derive a sharp point.
yeah, you can't derive a sharp point. So it would be impossible for us to algebraically, well, actually you can set it up as piecewise functions, and you can do like the linear equations of the two. You can do it that way, but either way you're going to get a derivative that's not going to work. But you can look at the graph and say, I definitely have a minimum of what? 0 at which x value? 2. So just by looking at that, I can say, hey, I have a minimum. And, oh, it says absolute, by the way, so an absolute at f of 2 equals 0. Okay, and then how could I figure out the absolute max? Okay, so can you look at the graph and tell me where at 0 and 5 we would have the y values? I mean, don't assume I drew it perfectly to scale, but you could just plug in 0 and 5 in here if you didn't want to use the graph. You could just plug it in. So if I plug 0 in, I would get what? 2. And if I plug 5 in, I would get 3. So which one is bigger?
5.
Yeah, f of 5 is going to equal 3. Pretty easy there? Not too bad. Okay. Let's try finding the extrema of question number 9. So we're still finding mins and maxes. So how do you find, what do we do first? Derive. So first we're going to derive, so we're going to find our critical values. So if I derive this, I get what? 2x to the negative 1/3 minus 2. Okay, so my next step is now to set this equal to 0. And check this out, what happens. So I'm going to have, you guys in the back, stop talking. Okay, so if I take my negative exponent and put it into the denominator, that is going to end up giving me a critical value. Okay, so remember that anytime I have a value that is undefined, that's critical. Okay, so I can solve this, and I will also get a critical value at what? At 0, because x cannot be 0. Okay, so let's solve this. How would I solve this and isolate my x? Add the 2. Wait, what did you say? Okay, then how do I get the x out of the bottom?
Multiply it.
Multiply it out. So I would have 2x to the 1/3 equals 2. Then what? Divide by 2. So x to the 1/3 equals 1. So then to get rid of a 1/3 we'd cube. And 1 cubed is 1. So I have two critical numbers. I have critical numbers at x equals 0 and x equals 1. Okay, so my two critical values both exist in my interval. Okay, notice my interval is -1 to 3. So that means I'm going to have to test 4 numbers to see where my min and where my max lies. So we'll start at the bottom. So we'll start with -1. So if I plug -1 in, let's see, that would be 3 minus 2, no, 3 plus 2, right? Right? Hello, anyone? 3 plus 2? Right? Do you guys agree with that? Because if I have -1 to the 2/3, that's the same as -1 squared, which is 1, and then the cube root of 1. So that's still 1. If I plug in 0, that's an easy one. Can I just go straight to the end game? Yes? Critical numbers. Okay, and then if I plug 1 in, that's going to be the same as 3 minus 2. So 1. And then our last piece is plugging 3 in. Ooh. So this is going to give us a icky number, because we're going to have 3 squared is 9, and the cube root of 9 is not breakable. So this one, let's get a decimal on this. -6. Can someone type that in, or would you prefer me to tell you what that is equivalent to? Point. Oh, nice. Would you say 0.20? Okay, perfect. Okay, so let's do max. What's our max? -1. So f of -1. So technically our max is 5. So if I say, what's the max, you would say 5. Use the y value. And what's the min?
0.
0. Good. Whoa. Not too bad there? So finding extrema, thumbs up. Pretty easy, straightforward. Okay. Alright, so the second half of this is the mean value theorem. So the mean value theorem is kind of discovered by using these little functions here. So the examples say we're going to draw a secant line between the A and the B. And then the idea is that we're going to draw a tangent line that is parallel to the secant line. Okay? So what that means is my secant line is a line that connects 2 points. Okay? So if I connect the point A to point B, even though I said that wrong, you guys know what I'm talking about. Sorry, that is totally wiggly. Okay, so all I'm trying to do is find an equivalent place on that line that has the exact same slope. Okay, so I would say maybe like right here, this line right here is tangent to the graph and has the same slope. Does that kind of make sense what we're doing there? Okay, so if we go to question 11, if I connect these two lines, I don't know why I want to draw slow, it makes my lines wiggly. Where would you say the tangent line exists?
I like the tops of the curves.
Yeah, kind of like close to the top, right? Kind of like right there. And then, and also on this side too, like kind of close to the bottom there. Okay. Does that make sense?
Yeah.
So do you see, I'm just trying to match the slope of the line. Mm-hmm. Yeah, exactly. So I would agree with you. I don't think there is another place on that line that the slope is the same. Okay? So this is kind of one of those things where we have this cusp going on. That's what it's called, cusp. Okay, so when there's a cusp or like a really sharp kind of volcano-y effect, I guess, then there is no tangent line that exists between the A and B. Okay, so what do you say about 13? Okay, so how come?
Can't draw that through the old asymptote.
Okay, so we have an asymptote involved. That's a problem. So we have no tangent line. So hopefully you're starting to kind of notice when we don't have tangent lines. Okay. What about question 14?
Nope.
Yeah, no. It doesn't even have a secant line because I don't even have a point. There's no secant here. And if I can't have a secant line, then I definitely can't have a tangent line. Okay, so what's happening with 15? There's a hole right at the spot, so that's a problem. Again, we have no tangent line. Okay, so if you look at the questions that have no tangent line, can you give me kind of a blanket statement about when the tangent line does not exist? When it's not, what'd you say? Differentiable. Okay, exactly. So if the function is not differentiable or potentially continuous, well, I guess for it to be differentiable, it'd have to also be continuous, then we can't find that tangent line. So it has to be differentiable over the entire integral for that to exist. Should I say that one more time?
Yeah, one more, please.
Okay, so it has to be differentiable through the entire interval for the tangent line to exist. Okay, so the whole interval between A and B, including A and including B, right? Has to have endpoints. Okay. Oh, there's the solutions. That's good. We got them right. That's weird. Okay. Do you guys have this?
Yeah.
Oh yeah, I do. Okay. That was weird. Okay. All right. So this part is kind of drawing closer to the idea of that tangent line. So now, what we're trying to do is the C value is representing the X value where the slope is equivalent. Okay. So the same idea, I'm going to connect the 2 points. Okay, so it's saying that we have two points being the X values of 2 and 5. Okay, so if I was going to draw the line that's tangent to it, at about what X value would you say that exists? Okay, so I kind of think it matches right there. So I say 3 also. Would you guys agree? That the x value there where the tangent slopes are the same is about 3. Okay, what about number 17? Two and a half. So maybe 2.5. Yeah, I'd agree with about 2.5, and maybe about. What do you think about that one? Maybe like 4. I don't know. Maybe a little higher than. Yeah, sure. 4.75 sounds good to me. Somewhere in that ballpark. First one you think is what? Is what? 2.5?
No, for the. It's only in between those two.
Oh yeah, it can only exist in between the 2 points. Okay. What about 18? So you said, wait, what? 3? And yeah. So I think kind of like, yeah, maybe 2.5-ish. 3.5, maybe a little bit further on the 3.5 idea. Maybe 3.5. Sure, I can't really entirely disagree. Maybe 4.5-ish?
Yeah. Like 4.56.
4.56. Absolutely. Okay. So that's kind of like the visual representation of what we're trying to do here. Okay, so the next piece is, the idea is that we're going to take the secant line and try to match it to the tangent line. Okay, so if I want my secant line to match my tangent line, all you're going to do mathematically is literally set those two pieces equal to each other. Okay, so the slope of a secant line, do you recognize the slope of the secant line? Okay, it's just the slope between 2 points, y2 minus y1 over x2 minus x1. Okay, the slope of a tangent line is simply the derivative at the given point. Okay, some point, or some c values, what they're calling it. Okay, so we're setting the secant line equal to the tangent line. Got it? Okay. All right, here we go. So question number 19 is now the mean value theorem. Okay, so we're going to try to find where the slopes are the same. Okay, so do you want to work with the secant part or the tangent part? Okay, secant part first. Doesn't matter which one. So if we're working with the secant part, we're going to find the slope that exists between 3 and 6. So remember, 3 and 6 are both which kind of values? X values. Okay, so like this is my x1 and 6 is my x2. Okay, so for me to find the slope that exists between them, I have to find their corresponding y values. So how do I find corresponding y values? Plug them in. So if I find f of 3, maybe we can do this mentally. If I plug 3 into that x, I would have 3 minus 2. So would you agree that corresponding y value is 1? And if I plug 6 in, I would get 3 minus 1. So that corresponding y value is 2. Okay, so my secant slope, I'll just say m for slope. That sounds good. So y2 minus y1, let's say 2 minus 1 over x2 minus x1. So how about a slope of 1/3? Okay, so now I want to make sure that my function is continuous between my interval. Okay, so if I look at this as my function continuous within my interval. Okay, so when you look at your function, I see one spot where we have a problem. What's the spot that I have a problem at? Okay, when you have an x in the bottom, so what value makes the denominator 0? 0. So this has a vertical asymptote happening at 0. Okay, but do I care about 0?
No.
It's not in my interval. Okay, so I am okay there. If that was in my interval, then I would have to stop and I could not use the mean value theorem. I wouldn't be able to use it. Okay, so the function is, okay, it's continuous in this. Now I want to make sure that it is differentiable in the same interval, so I'm going to derive it. Okay, by the way, maybe it would be easy to rewrite the original function since I'm going to use a basic. If I have an x in the bottom, that's the same as x to the negative 1. Okay, so if I derive that, what would the derivative be? Good, 6x to the negative 2. So, if I rewrite that, that is the same as 6 over x squared, and I do have a place again that is not differentiable. Where is it not differentiable? 0. And am I worried about 0? No, I'm okay. It's not in my interval, so I'm okay. So now what am I going to do? What's my last step here? How do you use the mean value theorem? We set the secant line equal to the tangent line. So all I'm going to do now is I'm going to take my secant slope, which was 1/3, and set it equal to my tangent line and find the x value where they are both equivalent. Okay. So how would you solve that equation? Cross multiply? So I get x squared equals what? 6 times 3 is 18. I square root, the square root of 18, let's see. What perfect squared number goes into 18? 9. So 9 times 2, so the square root of 9 is 3. So 3 squares of 2, and we have a plus or minus. Okay, so the c value, that's the value where the slope, the x value where the slopes are the same. Remember, it has to exist within my interval. Okay, so of the two numbers that I just got, I have a negative 3 squares of 2 and a positive 3 squares of 2. Which one exists within my interval? Positive. Okay, so I can now conclude that the c value, that the secant line has the same slope as the tangent line, is at the x value of 3 squares of 2.
What a nice number.
All right. Okay, so that is it for you.